Yeah, thank you very much for the fun introduction, and thanks all for being here. I am kind of new to this scene, so looking forward to hopefully meeting a lot of you later on. But what I do hope to share with you is some perspective that I've built. Maybe part of it is coming from my physics background. I've co-founded this research institute, Simplex, where we're actually seeing that there's a hope to understand AI systems. And in fact, it's pointing more and more to intelligence is a thing that we can understand, that there's something convergent happening. And to the extent that's possible, we have more optionality, right? Currently, it feels like there's kind of something like optimists and doomers, and everyone's talking past each other because everyone has strong feelings, but there's no like truth to point to, right? So we're trying to build that basic understanding to understand like, what is the thing that we're building? What are the options for what we can build? And if to the extent we're understanding intelligence itself, we could even ask, what is it about ourselves maybe that we'd want to augment? So there's like some quite important things that we could get from understanding AI. So I think one of the basic things that I hope for, that I've already alluded to, is that understanding can elevate the conversation, right? So you have your kind of accelerationists and doomers, or however you want to classify it, but this comes down to, where do these different feelings come from? There's some crux. And it might be something like this, that on the one hand, you might think, hey, this is a technology and it's happening real fast, but we've dealt with technologies before. We'll deal with it, right? So don't be a Luddite. And so maybe then you just get like something like alignment by default, or like this will work out, like good things are going to happen, let's go. On the other hand, there's a lot of folks that think, this isn't great by default. It's not even just another technology. This is maybe something more like a species, and we've never dealt with that before. And if that's the case, then what do we do? Certainly not alignment by default. It's not even clear if it's possible. So this is some kind of majestic figure here, but the idea is, if we have some type of understanding, we can start to have conversations. Otherwise, we kind of cross our fingers and see who's right. So a few of the types of questions we can start getting to and refining are these things like, is AGI a new tool, a new technology, or is it something more like a new species? How could we refine that a bit? Well, one of the concerns you might have about something more like a species is that it could have its own desires. And Evan talked about the possibility of alignment. But if something's autonomous and anything has valence, that could kind of bootstrap, right? It would get a bit out of control. So an important question is, if we understood this thing, we can ask, could intelligence be uncoupled from desires? That feels pretty important to know. I suspect no, but we're building the science to figure that out. And then, AI is not just an input-output thing, despite some people think it's magic. There's like an internal to the system, the way that we're not just input-output, we have some internal state. And then we can ask the question, the mind of AI, is it like us, or is it different? Do minds kind of converge if you're sufficiently intelligent, or are there fundamentally different ways to represent the world? But this is quite important for many reasons, and I'll get to that a bit. I've already mentioned we can ask more about what we're building and what it is that we want to become. So just a bit about my journey from physics to interpretability of neural networks and this new science of intelligence. I did my PhD and postdoc at Davis. I was a research fellow in Singapore for a long time and co-founded a theoretical research institute, Beyond Institute for Theoretical Science, to ask more ambitious questions. I was supposed to move to Spain to help start up a new quantum information institute, but I was feeling pretty uneasy with the trajectory of AI and was thinking, we really need to figure this thing out. So was really grateful for the maths program. I think Ryan Kidd might come up later and talk about that. Kind of helped with this transition, give me some space to think about it. I was at IPAM with Josh during this Mathematics of Intelligence program, co-founded Simplex, and we have sustained support now from Astera Institute, where I'm research lead on our Simplex organization. I think this crowd might also be interested in kind of the funding landscape here. So we have support from Astera Institute. We also have support from Coefficient Giving, formerly OpenPhil, and the UK AI Security Institute. So it's great that these entities exist and they are supporting fundamental understanding, but it is kind of like embarrassingly little amount of investment compared to the amount being dumped into capabilities and how fast it's going. So, I think we could certainly take more funding, but in general, like this ecosystem deserves, like we deserve to do the best we can to understand what we're building. So I'm going to just lay out some kind of basic, maybe even sounds silly, but some basic observations. Just like physics first principles. Okay, I'll take the, I feel like you gave me permission to think from first principles, so thanks for that. Maybe this is a bit of a humanist thing, but I would say that humans are worthy. What do I mean by that? Well, worthy of rights, love, protection. I'm going to take for granted that you all agree with me on this. Okay. But at the same time, we're not that special in the sense of, from a physics perspective, we're just squishy kind of blobs of matter. We've been shaped by environmental pressures and compounding accidents that managed to eke out a semblance of intelligence. So like this just kind of happened by accident, that like a squishy thing can be intelligent. Like that wasn't the goal kind of at the beginning, right? So we're not in any fundamental way like a pinnacle of intelligence. But then you can think, well, what if we actually made intelligence on purpose, right? Because we are proof of principle that a physical thing can be intelligent. Okay, physical things can be intelligent. But what if you made it on purpose? Well, then there's no reason why like human intelligence should be this pinnacle. It would like just blow past us, right? And it seems these days like we have basically figured out whether it's this current paradigm or something slightly different. So here we go to superintelligence. But there's this other point that we're not only proof of principle that physical systems can be intelligent, we've already agreed that we're proof of principle that physical systems can be worthy and curious and cruel and kind, but we need to know which of these things can be uncoupled or not, right? So there are a few efforts in this direction. So, for example, I'm part of a consortium looking at agency intentions and artificial intelligence. Really happy about this group. I think there should be more efforts in this direction. Well, and this does seem to be, an actual problem. There's, I think there's so many different news articles I could give. This was even from too long ago, that AI systems seem to have something like desires that it's like, oh, I want to persist, that they're blackmailing engineers. And so there's some call for alignment. As Evan pointed to earlier, that might not even make sense. Alignment to human values, whose values? But even if that made sense, prerequisite to that would be alignment of concepts. Do they even represent the world the same way? Because you need to be able to talk about the same things, prioritize the same things, right? So alignment of concepts, and then that gets to the question of how do these things represent the world? So that's really what we're going after. That's what our Simplex organization is doing. And kind of as a first pass to that, I've already mentioned human intelligence isn't any kind of barrier to artificial intelligence. That's even true for current LLMs that are trained on human language. I think you say, well, it could never learn more than what it was trained on, that was made by humans. But one key point to that already is that these models are trained to fundamentally predict rather than to generate, despite the name generative pre-trained transformers. They're trained to predict, and that is a fundamentally harder task and requires an understanding of the world which is already superhuman. And then beyond that, just self-supervision, predicting the future from the past. This is a boundless source of intelligence and knowledge. So,
why is prediction superhuman already, or superhuman? We not predict.
We do predict, but an AI model would predict your next actions much better than I would predict yours. Like, you can generate your own actions better than the name on it.
SI prediction would be super. So you
Yes, the task of prediction as well as possible. Like, if you,
yeah,
like, to predict as well as possible, you have to understand everything.
if I spoke to you about AI and then a lot of this now, and it's bossy.
Yeah, like,
You're super good, but you're talking about
yeah, like,
time.
yeah, but the training objective of, say, next token prediction, I would claim, and kind of the theory bears out, that it is sufficient to, it's kind of like AGI complete. It is sufficient to get everywhere, right? And then there's some question of like, well, is this architecture efficient or not? Or, so I'll kind of take a step into some of the basic research that we've been doing on this to like get our heads around what are these implications of this next token prediction to get a better understanding of, are these stochastic parrots? They have some world model inside. Trying to get to basically a setting where we can have something falsifiable, again, to like bring people together to point at the thing. This is what this thing is. So in some very quite simple experiments, you can show, okay, there's some like ground truth of where data is coming from. And then you train a model on that standard next token prediction. And what it learns to do is not only to develop a world model, but moreover, it ends up learning how to do belief updating over that. So just like Bayesian updating, as I observe more text, more tokens in context, I do inference over my world model. That is fundamentally what AI models are trained to do. So you can just see this at a behavioral level, which already implies in context learning. And then you can ask, well, is that actually what's going on inside? Because it's just behavioral. And so a lot of the work that we've done is then on, if we can get to the next slide, is more on the representational question. So we've created this falsifiable setting where, let's say we just take a 3-state hidden Markov model, for those of you that are familiar with something like that. If we train a model on that, what would we find inside? It's not just that there's some nodes and transitions, but we actually anticipate it's going to have this crazy fractal geometry corresponding to updating beliefs over some model of its world. And then over the course of training, indeed, you see this emerges linearly in the residual stream of the transformer. So models do have this world model, at least in this simplistic scenario, and it seems to extrapolate. And so we can push the science further and say, actually, we can look at different layers, and it's not just that we observe some structure. We can actually anticipate what it is. So we're starting to get a grasp of this thing. And moreover, the geometry that we find inside of models is universal. So if you're familiar with architectures, transformers, LSTMs, basically RNNs, very different, but they're coming to the same representation of the world. One more thing I want to point out is that it's not what you might expect. It's not that there's some like hidden Boolean circuit. The computations going on inside is more akin to quantum computing because it's taking advantage of the real vector space. And if we didn't do the basic science, we wouldn't know for that. So if we're trying to do interpretability and you don't even know the type signature of the thing you're looking for, that's a problem. Another reason to understand, what it is that we're building here, invest in understanding. So this is supposed to be a video, but is very cool in that it shows the development of these representations over training. If the world has many parts, you don't know that a priori. How is it that we get a stream of data and then discover that, oh, this is a coffee mug, another human, another agent? It turns out that models do this automatically because there's a pressure to represent things in low dimensions, which this is kind of a fun thing that I've finally learned about myself. I've always been fascinated by kind of, holism, and I think we all are. Why is it this reductionist thing? It turns out that there's an exponential representation advantage, a dimensional advantage, to breaking the world into parts. And so reductionism actually is like mathematically motivated, which is interesting. But this is also good for interpretability because it means that the model is going to chunk its representational space into parts of the world. And so we don't necessarily have to understand everything all at once. We can probably find interpretable subspaces and then see how those things compose, what feeds into a space, and so on. So there's some hope. I hope that's what I'm getting across. That like we're just at the beginning stages, but actually there's a there, right? There's some foothold. And if we invest enough in this thing, then we can we have to keep up with capabilities. So this is kind of crazy, but like there's a there, and it really deserves, I think, the investment. Instead of hoping for the best, we can build for it if we invest sufficiently in understanding and regulate powerful capabilities and opaque models. So I've probably left you with more questions than answers, but I do want you to think about these questions. What understanding of internal structure would allow us to trust AI behavior? And to the extent that we're understanding intelligence itself, what would we choose to become if we could augment our own intelligence? So I'll leave it at that I'm afraid we're not prepared. We should invest in understanding, create optionality. We can then potentially roll out capabilities that we trust. We can choose what we want to build and what we want to become. So thank you.
All right. Wait, don't leave the stage yet. Okay, I have a quick question because I want you to help the audience contextualize that. We just heard from Evan, who's talking about, yesterday we heard so much about alignment research and how important that is. Essentially, we call, I've been saying it's just like therapy for neural networks, right? You're really trying to use psychology to get them to not do bad things. And what he just talked about is essentially probability programming and using mathematical gates to create containers around them for certain use cases. Given that we just heard all this research and all these advancements, in a way, it's like you didn't move to Spain to do more of your quantum work, but in a weird way, it's actually come back, right? Because you're saying like you need to have that quantum understanding for a lot of this emergent findings. Turns out. But how could you help us vision what is your reaction to Evan's talk? Like, how does your work intersect with what he's telling us about a set of situations or contexts where alignment training is not enough? How do your findings intersect with that work, or how do we understand it?
Yeah, I appreciated Evan's point that like alignment might not even be a well-formed question. Like maybe it's a stupid question,
which is what you essentially were implying, and that it's like not. It's that's right. Maybe too narrow.
And to the extent that I understood kind of the main point there, it's like alignment's not enough, so we need to like coordinate. But I would argue coordination's also not enough by default. Like we actually need the understanding to say what we want to coordinate around. And that could be coordinating not to build AGI, or it could be coordinating to say, we're only going to build the AGI where we can show that we separate intelligence from desire, right? Or something like that.
Okay, well, help me understand over question, because I'm like so fascinated by this before our next speaker. And so I'm being a little greedy with time here. But as a sociologist, we see systems and structures. So how do you think about desires as coupled to as embodied AI or embodied systems or embodied intelligence? Where does that come in for your work as a theoretical physicist talking about this?
Yeah,
and experimenting with it essentially, or
creative
mathematical.
So there's a few levels at which I'm tempted to answer this. One is like most directly tied to the experiments that we're doing. So we find that models are breaking the world into parts, and one of those parts could be kind of a model of self. And then you could start to look at how does that what is that self? So you could look at that. But I think like even just more fundamentally, and I think this has very little to do with physics, you could imagine that if you understand the world deeply, and if anything at all has valence, and if you're an autonomous agent, that valence kind of bootstraps, right? And so if you have priorities and they're not exactly the same as what? Well, there's no target. We can't say what it should be the same as. So anything with valence bootstraps, and
because anything with valence wants to keep perpetuating itself, and that kind of therefore even is a desire.
Yeah, and we've already observed with current technology, like there is valence for like persistence or for like animal welfare. It's like these all seem like
Or just
fine.
attending to like any goal.
Yeah, attending to any goal, right?
Already like innately has the tendency to persist itself towards the success of actual.
Yeah. So if you have intelligence in valence, there will be some like self-reflection, it seems. And that kind of allows to like reconsider what are my priorities. And so like let's say somehow you like one time aligned a system, like if it's actually intelligent, it's going to like reevaluate, like, is this actually what I care about, right? So it's like, it is a very hard problem. And basically, if we build the basic science, there's a lot to do, but we can again, hopefully have more of a shared foundation for what we're building.
Well, I would love to see a conversation in the future between you and folks working on embodied, AI, embodied intelligence, and even more of the, future kind of world building, world models that are going to be taking in more inference and real-time knowledge from real-time intelligence from our space. So thank you so much.